Hello and welcome to the first video in a series of videos on the protection of transformers. Today we're going to cover the faults, the typical faults, and the main types of protection against these faults in transformers. A transformer is an electrical device that transfers electrical energy between two or more electrical circuits by electromagnetic induction. Transformers facilitate transmission and distribution of power by allowing us to either step up or step down voltages. So stepping up voltages is particularly important for transmission over long distances with minimal power loss. So transformers play a crucial role in ensuring that um, electricity reaches our homes, our businesses, and our industries. So it is very important that we safeguard and protect transformers from faults and also ensure uninterrupted power supply. So before we look at the main types of protection schemes for transformers, let us explore the faults that might compromise the operation of transformers. So let us look at the main types of faults and abnormal operating conditions of transformers. So first up we have internal faults. These are faults that occur either inside the transformer or at its terminals. They can further be classified as winding and terminal faults. These can either be phase-to-phase, interturn, or winding to earth. So phase-to-phase meaning between phases, and then interturn meaning between turns on a singular winding, and then winding to earth, that is between a winding and the earth. So these faults are accompanied by heavy fault currents which can cause damage to the windings and burn out the core. So it is important that our protection acts immediately to disconnect the transformer in case of this type of faults. So core faults, these are faults that occur when a conducting bridge is formed between laminated core structures. They lead to an increase in core losses in the transformer and also an increase in eddy currents. So these faults have to be detected, and they're quite hard to detect. Usually they're detected by the buildup of gas due to the heating caused by these faults. So these faults also cause heating and reduced efficiency of transformers. So it's very important that they are detected and disconnected. Next, we have tank faults. These occur due to gas pressure buildup, oil leaks, or degradation, and cooling system failure. There's nothing more to say about that. And here, lastly, on internal faults, we have on-tap changer faults. So these are issues or faults that occur in relation to the on-tap changing mechanism of a transformer that we use to adjust the transformer ratios when it's energized or loaded. So we do this in order to vary the voltages to compensate for power fluctuations in the system. So us doing this leaves the transformer vulnerable to wear and damage of the contacts or mechanical faults. So that's something we have to look out for as well. And then external faults, these are faults that occur downstream of the transformer. So our transformer isn't the first line of defense here. It's our transformer's protection acts as backup. So the backup of this downstream equipment, for example, the feeders, or if this fault occurs, an external fault occurs in the bus bars, the protection of these individual equipment should be the first line of defense. But in the case of failure of such equipment, then our transformer works to um, isolate the damaged or the faulty areas. So they can be classified as system faults and overloads. So these system faults and overloads, that they cause heavy fault currents to occur, and also they just cause heavy currents to occur, high currents, and they also cause heat to be generated in the system in our transformer. So our transformer must work to disconnect in the case of these faults. So reduce system frequency and over voltages. So let me start with over voltages. So over voltages might be caused by either uh, transient over voltages or due to an alteration of the system frequency. So transient voltage surges occur due to uh, a fault in the system, switching of the during switching, and also during lightning disturbances. So there's over voltages cause damage to the system. And then next we have reduced system frequency. Like I said, reduced system. Like I said, over voltages might be caused by either transient surge, transient over voltage surges, or they might be caused by frequency alterations. So an example is if we increase the frequency in the power system, this leads to an increase in the flux, and this in turn leads to an increase in the magnetizing current, and that leads to more flux being diverted, and this causes a rise in temperature in the system. So that is also not uh, ideal for our transformer. Now let us look at the types of transformer protection. So the types of transformer protection can be classified as either main types of protection or backup protection. So in this diagram we've shown 5 types of transformer protection, and the first one is differential protection. So differential protection is the main type of protection in high voltage transformers. It involves measuring the current entering the transformer and the current leaving the transformer. So a difference in this current indicates a fault within this protected region, and our protection then, after detecting this fault, quickly works to isolate the transformer and prevent further damage to our system. Next, we have thermal protection. So thermal protection, indicated here as 2, is well, during normal operation of transformer, heat is generated, but during prolonged use or during overloads, this heat exceeds predetermined values, and it might sometimes cause degradation of insulation, and also it's the potential failure of the insulation. So for this reason, we place temperature sensitive devices in the temperature to monitor abnormal rises in temperature and trigger the thermal protection to protect our transformers. Next, we have gas pressure protection. So this one here, this protection is mainly used in oil field transformers. It during a fault, for example, the heat generated might lead to the vaporization of oil, causing abnormal levels of pressure to build up. So our gas pressure protection must detect these abnormal rises and act to protect our transformer. And then we have backup protection. So under backup protection, so one thing we should say about backup protection is it is the second line of defense. So it occurs in the case of failure of the main type of protection. So earthwork protection, it an earthwork occurs when the windings or the iron core of the transformer is inadvertently connected to the earth. So this leads to current imbalances in a three-phase system in the transformers, and so our earthwork protection measures these imbalances and moves to disconnect the transformer in the case of such faults. And then lastly, we have overcurrent protection, which is a mandatory backup protection. It involves, that's the overcurrent protection is the one indicated here as 5. So it involves monitoring the current, and if the current exceeds a predetermined value, this overcurrent protection works to disconnect the transformer and prevent further damage to the system. So these are the 5 main types of transformer protection, and we are going to look at them individually in depth in the next video. So if you've made it this far, thank you very much for watching. Please like, share, or subscribe, or don't, no pressure. And goodbye.